All right. So now that was commutative property for you, and we discussed closure already. And let's come to associative. So what is associative? Shaurya? You can, I'll keep it here. So this is division, this is addition, and multiplication. We can understand it is pretty much going to be the same. So that is multiplied negative 2 by 3 with minus 1 by 3, or it would be the same as if you divide by multiply negative 1 by 3 with negative 2 by 3. It's still
Yes, sir.
going to give you the same result. It is 2 over 9. So multiplication, it is commutative. It is commutative in addition also. It is not commutative. And also not commutative in this case.
Okay, sir.
And let's come to associative. Can you see over here? So associative is basically related to three numbers. Association is always discussed when we have three different numbers. Like earlier in previous grade, we talked about associative property with respect to integers, even whole numbers. And now we're going to discuss about associative property in terms of rational numbers. So there are three numbers, which is A. A can be 1 over 2, it's a rational number. B can be negative 1 by 3, and C is minus 1 over 4.
Okay.
Okay. So this is what we have, three numbers. So associative is basically saying, if you're talking about, let's say, A plus B plus C, like addition of three numbers. So would it matter if you the bracket around B and C? That means if you were to add B and C first, and whatever be the result, if you were to add to A, would this result be different than if you were to do A plus B first and then add it to C? What do you think?
No, sir.
It would not, right?
Yes,
So
sir.
addition wise, it is pretty clear. Like there is no difference when it comes to addition of three rational numbers also. So we say that addition, it is associative.
So can it be like A plus C in brackets plus B? That would be also equal, right?
It can be. These results are going to be same.
Okay.
And you can try it for yourself also, right? Now, the same is true about multiplication. So that means if you were to do A into B into C, whether you did B into C first or you did A into B first and then multiplied by C, or you did A into C and then you did B, these results are all going to be the same.
Okay, sir.
So multiplication is also associative. But this thing cannot be, cannot happen when you have, let's say, something like, A minus B minus C, something like this. And you place a bracket here, or you place a bracket here. Can you try what will happen in this case? What results you get? What do you
So
get?
A would be 1 by 2 and minus B minus 1 by 3 minus.
And also do this, A minus 2 minus 3. What do you get in each of these cases? I'm going to just replace the values so that you can look at it. This is for the first one. For the second.
The first answer is, so it would be 5 upon 12.
Okay, what about the second?
So I'm calculating.
Okay.
So I'm getting the same answer for second and third.
Second and third also?
Sir, second was -1/12 and third is also -1/12. I don't know how I'm getting the same answer.
Okay, but it is different from the
The
first one.
first answer.
So this would be, let's see, 6 or 3 plus 2 plus 1 over 4, which is 5 by 6 over plus 1 by 4, which is going to be 12 or 10 plus 3, which is 13 over 12. This is 13 over 12.
Okay.
And first one I'll check again. 4, I'm talking just about this bracket.
Yes, sir.
2 plus 1, which is 3. So half plus 1 by 4 will be 3 by 4 plus 1 over 3 gives you 4 and 3 is 12. So 3 times 9. 3 times 9 and 4 times. Yeah. So yeah, you are right that these two are coming out to be the same. Correct. In this case, these are materially the same thing, but you would see that this is still different than the first one. So this would be 1 by 2 minus within bracket 12. This is plus 1 by 4 minus 4 plus 3, which is negative 1. So 1 by 2 minus 1 over 12, or it would be 12 6 plus 1. That is 7 over 12. SS.
Okay, sir.
Got it?
Yes, sir.
So how we did it? We have to take it step by step. This negative and negative, if you remember, this will turn into a positive value. Hmm?
Okay. I think so. That's what I'm here. Sir, but how the second and third are same? I don't get that.
Oh, it's just the fact that if you drop this bracket, because it's in the front, so if you can drop this bracket, ultimately this negative number, these can be switched places, right? There is no problem with, you can imagine there is a addition in minus c and minus d. So you can very well move this minus d over here, keeping the c at the last. So that's the
Okay.
reason why there is no difference between this and this. That's why we always just define that these two, between the two, because the third form is anyways similar to the second form. It just is a matter of convenience that we can write it in a third way, but it will turn out to be the same because the bracket has already been placed. The second number can be switched with the third number. There won't be any difference.
Okay, sir.
Yeah. So associative property, addition and multiplication, it works. It doesn't work for subtraction. And do you think it would work for division?
No, sir.
Can you justify that?
So, as I think so, that would not come as equal as we take three numbers and divide them. I think so that would not come as equally as, I don't know. I think so it's not compatible with division. same as maybe.
So we see division, okay? So A divided by B divided by C. So whether we divide B by C or we divide A by B and then divide by C. And let's take these numbers itself, okay? One, so now if we take this case, 1 by 2 divide by minus 1 by 3 divide by minus 1 by 4. It will be these are negative, so basically negative. If you divide it, the result would be a positive value, and this is basically saying multiply by the
Yes, sir, reciprocal.
reciprocal of it. So 4 will be in the numerator. So 1 by 2
Divided by 4 by 3.
4 by 3, right? Again, we
Yes,
do the
sir.
reciprocal, so we get 3 over 8,
Yes,
isn't
sir.
it?
Yes, sir.
Now let's do the second part. So 1 by 2 divided by negative 1 over 3 divided by negative 1 over 4. So how much is it?
So, for the brackets to solve, it would be, sir, 3 upon 2 minus 3 upon 2 divided by 1 by minus 1 by 4. So, which would be equal to 2. So 6 upon minus 1. So which would be, I think so, minus 6.
Which is minus 6. And so they are two different values.
Okay, sir.
Yeah, so we can say that associative works in this case, it doesn't work in this case, it doesn't work in this case also.
Okay, sir.
Does it make sense?
Yes, sir.
Okay. So you can take it down, like if you want to take a screen grab of it.
Okay, sir.
Good
Yes, sir.
afternoon, sir.
Done.
Good afternoon, how do you do?
Sir, good. How about you?
I'm fine, thank you for asking. I will start at 4 p.m. Okay, you want to stick around and just
Yes,
watch
yes,
this?
yes, sir. No problem.
Okay, I think Paki is also in, so let me allow. Have you taken the screen?
Yes, sir.
Okay. Now we'll talk about now. We have covered closure, we covered commutative, associative, and let's see what this is, distributive. Is everyone staying safe now?
Yes, sir.
So what is distributive property? Shah, any idea?
Yes, sir.
Hmm.
So as the property distributive, so if you write A, sir, can you write, sir, A plus B, B plus C, and sir, BC in bracket. Oh no. Oh, sorry, sir. It only works. No, it. Sir, distributive, does it work in addition also or also in multiplication. I'm not sure.
It is between two operations. It is a multiplication and addition, and it is multiplication and subtraction also.
Okay. Sir, so I was trying to say that if we open the brackets and if we write AB, AB minus AC.
Like here?
Yes, sir. AB minus AC. So that would come out as our distributive property. But we have opened the brackets and we have A is multiplied by B, which is subtracting, and A is multiplied by C also.
But you see there is a plus operation here.
Yes, we can add our addition or subtraction sign.
So
According
the
to
sign, yeah, this sign is the same sign which we see here.
Yes, sir.
So if it is a negative, then we do a difference here, like this.
Okay.
One thing for sure. So what we are saying is that I'm distributing A with to B as well as to C. That's what is happening over here. And I'm doing distribution to B as well as to C is what is happening over here. But the difference is that it is a distributive property of multiplication with addition. And this is a distributive property of multiplication with subtraction. That's the
Okay, sir.
difference. And it's a very fundamental thing. So we do use a lot of it. So it's absolutely important to be clear on this. Huh? Now, coming to rational numbers, this rule is very valid even in the case of rational numbers.
Okay, sir.
That means if you take any three rational numbers, A, B, and C, they would follow this.
Okay.
Okay?
Okay, sir.
So say for example, again, we take the same example, A as 1 by 2, B as negative maybe 1 by 3, and C as 1 over 4. And whether you do A into B plus C, that means first you add B and C and times it or multiply it with A. Whether you do it this way or whether you do it on the right-hand side way, or which means you multiply A with B and then you multiply A with C and then you add them all.
Okay, sir.
The result is going to be the same.
Okay.
So that this rule is that means valid for rational numbers also. And you can understand all the natural numbers are rational numbers. So if it works for natural numbers, it would work for rational numbers or numbers which have P over Q form, right?
Yes, sir.
So it should work for them as well.
Okay.
So let's keep it simple and keep it till here, and we'll continue tomorrow from the rest of the properties which we have to cover in this and a little bit more which is remaining in this chapter. I'll share some questions with you later today, maybe in a couple of hours.
Okay, sir.
All right.
Yes, sir.